What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 2, Section 5, Quadratic Equations. Let's do it. How do we recognize when an equation is quadratic? That's when the highest degree is 2. So, for example, if we had x squared minus 4 equals 10, this would be a quadratic equation because the highest degree is 2. When we solve a quadratic equation by factoring, why do we move all the terms to one side, having 0 on the other side? So the reason why we do that is because when we're solving a quadratic equation, we're factoring, we're breaking it up into two different binomials. And the zero product rule comes in really handy here because let's say I factored into x minus 7 and x plus 3. It becomes a much simpler equation because if it's two things multiplying each other and we're trying to get a result of 0, as long as this one piece equals 0, the entire function goes to 0. Likewise, if this one piece equals 0, the entire thing goes to 0, because anything times 0 is 0. So what makes this binomial go to 0? 7 minus 7, so when x equals 7. What makes this one go to 0? When x equals negative 3. Negative 3 plus 3 is 0, and that's how we get our solutions. Describe two scenarios where using the square root property to solve a quadratic equation would be the most efficient method. So the first would be if we simply had x squared equals 64. In this case, I can just take the square root of both sides and get x equals plus or minus 8. Don't forget, when we're solving in an equation context, we need to acknowledge that the square root of 64 is both positive and negative 8, because both, when multiplied by themselves, gives 64. Another example is if we had a perfect binomial square like this, isolated, and then equal to, let's say, 16. So again, here, instead of foiling out and setting equal to 0 and then factoring, we could just take the square root of both sides, and we get x plus 8 equals plus or minus 4. Then by subtracting 8 from both sides for both the negative 4 and 4, we'd get two solutions, right? Negative 4 minus 8 would give us negative 12, and then negative 8 plus 4 would give us negative 4. And then if you plug these back into the original, you'll see it works. You'd get negative 4 plus 8, which is 4. 4 squared is 16. Negative 12 plus 8 is negative 4. Negative 4 squared is 16. Boom, done. All right, to solve this equation by factoring, first we're going to break it into two binomials, and we're going to figure out what the binomials are as follows. What two numbers multiply to 18 and add to negative 9? That is going to be negative 3 and negative 6, right? Multiplies to 18, adds to negative 9. Now, what are the solutions? What makes this go to 0? Positive 3. What makes this go to 0? Positive 6. Those are your solutions. Done. In this one, we have a leading coefficient, which means we have to use the star method to factor. So again, if this is my A, B, and C, I put the A up here and here. That would be 6 and 6. I put the B down here, which is 17. And then I put A times C, 6 times 5, up here, which is 30. What two numbers multiply to 30 and add to 17? That would be 2 and 15. Then we're going to reduce these like fractions. 6 over 15 reduces to 2 over 5. Divide both by 3. And then 6 over 2, divide both by 2, and we get 3 over 1. So this is how it factors into 3x plus 1, that's these parts, times 2x plus 5. And this still equals 0. So now the question is, what makes this go to 0 and what makes this go to 0? So if you're not sure how to do this mentally, you can always set it equal to 0 like so, and then solve for x. So you can just say like, okay, I'm going to subtract 1 from both sides, and then I'm going to divide it by 3. So we got negative 1/3. But the way to do it mentally, if you want, is we're trying to get this to turn into negative 5. So if I multiply 2 times negative 5 over 2, that will give me negative 5. So it's kind of like you take this number over this and then negate it if it's a plus. So the other one would be negative 5/2. These are the solutions. Done. The first thing I'm going to do is I'm going to factor out a GCF, which is 3. Both are divisible by 3. So then I got x squared minus 25, right? Because 75 divided by 3 is 25. Then I've got a difference of squares. So check this out. This is really nice. I can do x minus 5 times x plus 5 equals 0. Okay, now we got a simple task. What makes this go to 0? Positive 5. What makes this go to 0? -5. Those are the two solutions. Done. Now, by the way, we could also solve by adding 75 to both sides, dividing by 3, and then just taking the square root. It's an alternative method, whatever you prefer. So for this one, once again, we're asked to solve by factoring. So we're going to follow the same protocol. We're going to subtract 9 from both sides and set everything equal to 0. Now, what you'll notice is this is a difference of squares, which means this is a perfect square and this is a perfect square, and it's subtraction meaning difference. As such, we're going to factor it as follows. We're going to factor the square root of 4x squared, which is 2x, place that here and here. And we're going to take the square root of 9, which is 3, place that here, and then alternate with plus, minus. And then we're going to say what makes this go to 0. Remember my little trick. It's going to be this value over that value, but then negated. And then it's going to be this value, which is actually -3, but I'm going to write +3. So it's going to be -3 over 2, but then negated, which is going to make it +3/2. So here are your solutions. Boom, done. All right, here I'm going to set everything equal to 0 first. So I'm going to subtract 5x from both sides. I'm going to subtract 30 from both sides, and I'm going to set it equal to 0. Then I'm going to divide everything by 5. I don't even need to factor. I can just divide, because I can divide both sides, and that 0 divided by 5 is 0. So it just goes away. So now I have x squared minus x minus 6, because 30 divided by 5 is 6. Now I can factor. So again, we use that idea, what multiplies to -6 adds to -1. That would be -3 and +2. So now my solutions are what makes this go to 0, which is 3. What makes this go to 0, which is -2. Boom, done. So in this case, what we're going to do is we're going to factor out the x. So this is when there's no c term. So I'm going to factor out the x, and then I've got 7x plus 3. And we've basically got it split up into 2 pieces, which is what we want. So when we say what makes this go to 0, that's just 0. And then what makes this whole thing go to 0, that's -3/7. Again, I take this divided by this and flip it since it's a plus. So those are my 2 answers. Done. So in this one, we're using the square root property, which is pretty straightforward. We just take the square root of both sides. Boom, boom. And just don't forget, we're taking plus or minus. So square root of 36 is 6, but it's plus or minus 6. Those are the two solutions, +6, -6, done. So in this case, I've got a square and a square. I'm going to square both sides, or square root both sides, excuse me. Square root of x minus 1 squared is x minus 1. Square root of 25 squared is plus or minus 5. So that gives me 2 equations. X minus 1 equals 5. X minus 1 equals -5. Then I'm going to add 1 to both sides, and I get 6. Add 1 to both sides, and -5 plus 1 is -4. Those are my 2 solutions. Done. Here I'm going to square root both sides, and I get 2x plus 1 equals plus or minus 3. Because once again, square root of 9, we have to take the positive and the negative root. So I'll break this up into 2 separate equations, equals +3 and -3, and then we'll solve, subtract 1 from both sides. 2x equals 2, divide both sides by 2, and we get x equals 1. Over here, we're going to subtract 1. We get 2x equals -4. Then we divide both sides by 2, and we get x equals -2. Those are the 2 solutions. Done. Here we're going to solve by completing the square. So I'm going to show you the steps for completing the square. So first, I'm going to add 22 to both sides. So I got x squared minus 9x equals 22. Then what I'm going to do is I'm going to take half of this middle term, this x term, the b term, and half of that is 9 over 2. And I know it's negative, but it doesn't really matter because then we're going to square it. And that squared is positive anyway, so it's 81 over 4. And I'm going to add it to both sides like so. Then what I'm going to do on the left side is I'm going to factor it. Now, you might be like, well, this is difficult to factor, but I've actually created a perfect square. So it factors to x minus this term, -9 over 2 squared. That's what we're doing. We're creating a perfect square by adding 81 over 4. If we FOIL this out, it would equal this. And then on this side, we just got to add these two together. 22 is the same as 88 over 4, right? If I put it over 1, I just multiply top and bottom by 4. Now I can add these together, and I get 169 over 4. Now I got a nice situation where I can take the square root of both sides, and I get x minus 9 halves equals square root of 169 is 13, square root of 4 is 2. But again, remember, this is going to be plus or minus. So now I got x minus 9 halves equals positive 13 halves. X minus 9 halves equals negative 13 halves. So I'm going to add 9 halves on both sides. So then here I got x equals 22 over 2, right? 9 halves plus 13 halves is 22 halves, which is 11. And here I would add 9 halves to both sides. 9 halves plus negative 13 halves is negative 4 over 2, which reduces to negative 2. So my two solutions are 11 and negative 2. Done. So again, we're going to solve by completing the square. So here we have x squared minus 6x. We've already got the constant on this side, which is nice, and which is what we need to start with. Then I'm going to take half of negative 6, which is negative 3, and I'm going to square it, which is 9, and I'm going to add that to both sides. Now I've got a perfect square on this side to factor. So it becomes x minus 3 times x minus 3, or x minus 3 squared. Again, the shortcut for that is going to be x and then this value plus that value. So x plus negative 3, or x minus 3 squared, equals 13 plus 9, which is 22. Now I'm going to take the square root of both sides, boom, boom, and I get x minus 3 equals plus or minus square root of 22. Now this is not a perfect square, so we kind of have to leave it as plus or minus square root of 22. Last step was we add 3 to both sides, and we get 3 plus or minus square root of 22. That encapsulates both solutions. Done. First, I'm going to start by putting the 2 alone. So I'm going to make it 6z squared. I'm going to minus z. And look, here the 2 is on the left side, the 6z squared is on the right side. It doesn't matter. So I just kind of flipped them around to make it easier for myself. Now we want to complete the square, but this one's a little tricky because we don't want to have 6 in front of the z squared when we're completing the square. So what we're going to do is we're going to divide everything by 6. So we've got z squared minus 1/6 z equals 2 divided by 6 is actually 1/3. Okay. Now we're going to still use completing the square as what they want. So we're going to take half of this b term, half of negative 1/6 is negative 1/12, and then I'm going to square it, which is going to be 1 over 144. So I'm going to add 1 over 144 to both sides, like so. So of course, this left side is going to factor into z minus this value, or plus that value, which is minus 1/12, and that's going to be squared equals. And then to get these to have common denominators, I'm going to multiply by 48 and by 48. So then it's going to be 48 over 144 plus 1 over 44, which is going to be 49 over 144, like so. Then I'm going to take the square root of both sides, like so. And we've got z minus 1/12 equals square root of 49 is 7, square root of 144 is 12, plus or minus. So now I'm going to break it up into two equations. Z minus 1/12 equals 7/12, and z minus 1/12 equals negative 7/12. Last but not least, I'm going to add 1/12 to both sides, and I'm going to get z equals 8/12, which is the same as 2/3 if we divide the top and bottom by 4. And this one, if I add 1/12 to negative 7/12, I'm going to get negative 6/12, which is the same as negative 1/2. So these are my two solutions, 2/3 and negative 1/2. Boom, done. Here we're going to start by adding 1 to both sides, and then so the minus 1 becomes a plus 1 over here. Then I'm going to divide everything by 2 and make it x squared minus 3 over 2x equals 1/2. Now I'm going to take half of this, which is negative 3/4, and I'm going to square it, which is going to be 9/16, and I'm going to add that to both sides. Now I've created a perfect square trinomial, and I'm going to factor it like so. Again, the shortcut is it's x plus this value, which is minus 3/4, without the square, of course. And that's what this whole side factors to. And that, of course, equals these added together. So I'm going to turn that into 8 over 16. Common denominators, 8 plus 9 is 17/16. Oh, and this is squared, by the way. Then I'm going to square root both sides, and I get x minus 3/4 equals Square root of 17 is the square root of 17. Square root of 16 is 4. Oh, and I also, sorry, forgot. When you take the square root, it's meant to be plus or minus. So this is going to be plus or minus rad 17 over 4. Last but not least, I'm going to add 3/4 to both sides, and I get 3/4 plus or minus square root of 17 over 4. Since they have common denominators, I can also rewrite it, but this is optional. I can also rewrite it in a slightly more simplified format as 3 plus or minus square root of 17 over 4. Boom, done. Here we are using the discriminant to determine the number of solutions. The discriminant is, of course, b squared minus 4ac, where this is a, b, and c. So b squared is 4 squared, which is 16, minus 4a is 1. That's the coefficient there. It's an invisible 1, times c, which is 7. So 4 times 1 times 7 is 28. So 16 minus 28 is negative 12. So the fact is it's negative. So what does that mean? If it's positive, it would have 2 real solutions. 0, it would have 1 real solution. Here it's negative. It has no real solutions. And there's your winner. Done. So once again, the discriminant is b squared minus 4ac. Here it would be negative 30 squared minus 4 times a times c. And negative 30 squared is, of course, 900. Here I'm going to take a little shortcut. 4 times 25 is 100, times 9 is 900. 900 minus 900 is 0. When it's 0, it means we have 1 real and rational. We know it's not only real, but it's rational because there's going to be nothing under the square root. 1 real rational solution. Boom, done. Again, the discriminant is b squared minus 4ac, where we've got a, b, and c. So it's negative 1 squared, which is 1, minus 4 times a, which is 6, times c, which is negative 2. So this becomes 4 times 6 is 24, times 2 is negative 48. But minus a negative becomes a plus, so we got 49. So it's positive. So since this is positive, we know we have 2 real solutions, but also since this is a perfect square, it's going to take the square root of that as 7. So it's also going to be 2 real rational solutions. Boom, done. For these problems, we're going to use the quadratic formula. And the first thing we need to do is set everything equal to 0. So I'm going to subtract 4 from both sides. And then we've got our a, which is in front of the x squared, our b, which is in front of the x, meaning it's 1, and 1 for a, and c right here. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug and chug. So we got negative b, which is 1. So it's negative 1 plus or minus the square root of b squared. 1 squared is just 1 minus 4 times a, which is 1, times c, which is negative 4, all over 2 times a, 2 times 1, which is 2. And then to simplify, we have 4 times 1 times 4, which is 16 negative, with another minus in front. So that becomes a plus 16. So it's negative 1 plus or minus square root of 1 plus 16 over 2. 1 plus 16 is 17. So my solutions here are negative 1 plus or minus the square root of 17 over 2. That's 2 solutions because of the plus or minus. Boom, done. Once again, using the quadratic formula, I'm going to mark this as a, that's a b is negative 5, and c is 1. The formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's go. So we got negative 5, which is 5, plus or minus the square root of negative 5 squared, which is 25. That's the b squared minus 4 times a, which is 3, times c, which is 1, all over 2 times 3. So 4 times 3 times 1 is 12. So 25 minus 12, 5 plus or minus square root of 25 minus 12 over 2 times 3, which is 6. 25 minus 12 is, of course, 13. So we got 5 plus or minus square root of 13 over 6 are the solutions. Done. So first we have to get this into our nice quadratic format. And you might be like, well, how do I do that? If you just multiply everything by x squared, it gets really easy. So then that becomes 4x squared. And then x squared times 1 over x, it'll become x squared over x, which just cancels into a singular x. And then x squared times 1 over x squared, simply x squared over x squared, or 1 with the minus there. And now we've got it in the right format. So now we've got a, b of course is 1, invisible 1 there, and then c. So we got our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's go. Negative b is negative 1 plus or minus square root of b squared. 1 squared is 1 minus 4ac all over 2 times a. As we simplify on the inside, 4 times 4 is 16. That's negative 16 minus negative 16 becomes plus 16. So it's like a 1 plus 16 becomes 17 over 8. And there are your two solutions. Negative 1 plus or minus square root of 17 over 8. Boom. For this question, we're going to use a calculator to solve. I'm not going to use the TI calculators, the Texas Instruments. Instead, I'm going to show you how to do this on Desmos. So I've simply written in the function like this, and these are what we're looking for. We're looking for the x-intercept. So normally we're setting it equal to 0 and finding the solutions for x. But when we're given the quadratic, what we're doing is it's like we're setting y equal to 0 by virtue of looking for the actual x-intercepts. So these are your two solutions rounded to the nearest thousandth. 0.131, and 2.535. So here are your answers, 0.131 and 2.535, boom, done. To find the answer to this, they're recommending we graph both of these individually and then find the points of intersection. So I'm going to show you how to do this on Desmos. So now we can see the two equations. This is y equals 4. This one is the quadratic. We look at the intersection points. And when we find the solutions, we're looking for the x values. So it's negative 6.653 and 1.653. So this one has to round to the nearest tenth. So we say negative 6.7 and 1.7, boom. Beginning with the general form of a quadratic equation, solve for x by using the completing the square method, thus deriving the quadratic formula. Okay, check this out. So we're first going to start by following our normal protocol. We're going to move that c value to the other side. So we got subtracting c from both sides. Then we want to get rid of that a. We don't want to have a leading coefficient. So I'm going to divide everything by a. So now I've got x squared, right? The a goes away. A over a is just 1. Plus b over ax equals negative c over a. Now as we're completing the square, we're going to take half of this, which is b over 2a, and we're going to square it. And I'm going to add that to both sides. So that's going to be b squared over 4a squared plus b squared over 4a squared. Now I'm going to factor the left side. So again, I've created a nice perfect square trinomial. And again, the key is it's going to be x plus b over 2a. It's going to be whatever this value is right there. Equals, and I want to combine these guys ideally. So if I multiply the top and bottom by 4a, I get 4a. And then here I get 4a squared. A times a is a squared. And now I can kind of consolidate that. So I'm going to put it as, since that's negative, I'm going to put that second just for fun. So I'm going to make it b squared minus 4ac all over 4a squared. So you can kind of see this is coming together as we might expect. So now I'm going to take the square root of both sides. And since the bottom is a perfect square, that can just become 2a. And on top, we can't really do anything with that. So that's going to just stay trapped inside as b squared minus 4ac. But once again, we're going to leave that plus or minus out there because we know that's a plus or minus radical. And then on the left side, we get x plus b over 2a. Last but not least, I'm going to subtract b over 2a from both sides. So x equals, I'll just make it a negative b over 2a. And then that's plus or minus this square root b squared minus 4ac all over 2a. Now here's the deal. They have the same denominator, so let's merge that. And it's going to become negative b plus or minus the square root of b squared minus 4ac all over 2a. And there is your quadratic formula. Boom, done. A person has a garden that has length 10 feet longer than the width. So I can say this is the width, this is the length that is 10 feet longer. Set up a quadratic equation to find the dimensions. The area is 119. So check it out. I know that W, width, times length, which is W plus 10, equals 119 feet. And they want us to use the quadratic equation. So what we're going to do first, we're going to distribute. We got W squared plus 10W. And then I'm going to subtract 119 from both sides in the same step. Because to use the quadratic, I want to set everything equal to 0. Okay, now to get the solution, we're going to do negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'll write it out up here. Okay, so b is 10, so we got negative 10 plus or minus the square root of 10 squared, which is 100, minus 4. A is 1. C is negative 119. That's a huge number. All over 2 times A. A is 1, so that's just 2. So negative 4 times 1 is negative 4 times 119 is 476 positive because the negatives cancel out. So we got 476 all over 2. That becomes 576, which I believe is a perfect square. I believe that's 24 squared. So square root of 576 is 24. So now we got negative 10 plus or minus 24 over 2. Now, here's the deal. We're going to get two solutions, but we're talking about width and length. So we're talking about positive values. So I'm not going to worry about the negative 24. So let's see. We don't have a ton of room here. Let's bring it up here. So I'm just going to worry about the positive value, negative 10 plus 24, because minus 24 would give us negative 34 divided by 2. That doesn't make sense. Divided by 2. So negative 10 plus 24 is 14. Divided by 2 is 7. And since we were talking about feet squared, the width is 7 feet. And the length would be 7 plus 10, which is 17 feet. And those are your winners. Done. Suppose that an equation is given here where X represents the number of items sold in an auction and P is the profit. How many items sold would make this profit a maximum? So we're going to do this by graphing. Now, when we're talking about a maximum profit, this is of course going to look like a parabola like this because that A term is negative. The maximum profit, because this whole thing represents profit, is going to be that max point. And when they say how many items sold would make a maximum profit, we're not looking for the Y value, because that would actually give us the value of the max profit. We're looking at the number of items sold to get this amount. That's the X value. So I'm going to graph it. I'm going to show you what it looks like. Okay, so you see how I adjusted the window as the instructions 0 to 200 on the X, 0 to 10,000 on the Y. But what we're looking for is we're looking for that vertex, and it's really nice on Desmos because it kind of auto finds it for you. And as we mentioned before, we're trying to find that X value. So that means 70 items will give us our max profit. The max profit happens to be $8,800, but they're not asking for that. So the answer is 70. Boom, done. The cost function for a certain company is this, and the revenue is given by this. Recall that profit is revenue minus cost. Set up a quadratic and find two values of X that will create a profit of 300. So profit is revenue minus cost. Therefore, the profit will be 100x minus 0.5x squared minus 60x minus 300. Because I'm subtracting this entire cost, we got to distribute that like so. So we're going to combine like terms, and we're going to get profit equals negative 0.5x squared plus 40x, right? 100 minus 60 is 40 minus 300. And we're trying to get a profit of 300. So I'm going to plug this 300 in for profit, and then we're going to solve. So that's going to be 300 equals all of this. Now I need to subtract 300 from both sides, and that's going to cancel that out. And I'm going to get 0 equals negative 0.5x squared plus 40x minus 600. This is what we want. Set it equal to 0. Now I'm going to try to factor this, but I don't like this negative 0.5x squared here. But I can remedy that by multiplying everything by negative 2. So I'm going to do it up here so I have more room. So we're going to do a little arrow like this, and boom. So multiply everything by negative 2. I get x squared minus 80x plus 1200. Now I'm going to factor this by asking what multiplies to 1200 adds to negative 80. That's going to be negative 60 and negative 20. Now to solve, what makes this go to 0? 60. What makes this go to 0? 20. So the two values of production are 60 and 20. Done. A vacant lot is being converted into a community garden. The garden and the walkway and its perimeter have an area of 378. That means everything total. Find the width of the walkway if the garden is 12 feet wide by 15 feet long. So we've kind of got this whole thing in the mix. And they're saying the entire thing, this entire width times this entire length is going to be 378. So let's set that up. Now, what is this entire width? Well, call it width, length, whatever. It's 12 feet plus x, which means it's 12 plus 2x's. What about here? It's 15 plus 2x's. Now let's create an area equation to relate everything. So we're going to say 15 plus 2x times 12 plus 2x. Gosh, there's not a ton of room here. Equals that 378. Now we got to solve for x, so we're going to do it as follows. First, I'm going to FOIL everything out, and we're going to simplify. 15 times 12 is 180. 15 times 2x is 30x. 2x times 12 is 24x. And then 2x times 2x is 4x squared. And this all equals 378 still. Now we'll combine like terms. I'm going to write it in the right order. So we got 4x squared. 30 and 24 make 54x plus 180 equals 378. Now we want to set everything equal to 0. Let's box this off. So I'm going to subtract both sides by 378. Then I have 4x squared plus 54x minus 198, and that now equals 0. Beautiful. Now I'm going to divide everything by 2 to simplify a little bit more. We got 2x squared plus 27x minus 99 equals 0. Now I'm going to factor using the star method. So we've got A, B, and C. So I'm going to set it up down here. So we've got 2, 2. We've got B, which is 27, and then A times C, that's negative 198 up top. So what multiplies to negative 198 and adds to 27? That's going to be 33 and negative 6. Now we're going to reduce these like fractions. That becomes 1 and negative 3. And this can't be reduced, which is nice. So it becomes 2x plus 33 times x minus 3 equals 0. What's going to send this to 0? It's going to be a negative number, so I don't care because we can't have negative length or width. But this one's going to be positive. What sends that to 0? 3, which means the width of this walkway is 3 feet. Boom, done. I hope you guys enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.